Who's got questions on the gram-mole conversions?
So a mole and the 6 point whatever to the 23rd are the same thing?
Yes.
Okay, that's all I have, thank you.
Yes. So I want to reemphasize that. Six point up 2 times 10 to the 23rd of whatever. Okay? So it does have a unit, it's just the unit is whatever you need it to be. Okay? Is equal to 1 mole of whatever. Now, if a question is asking about atoms, ions, molecules, particles, that's when you want to use it. Okay? If it's not asking you those things or giving you those things, don't use it. It's not something that's commonly used for us. We're primarily going to be living in the gram-mole world. I don't have a balance in the back that goes out and counts the atoms. Okay? I have all of my balances measure out in grams, which means we can measure in moles if we do a conversion, but we rarely, if ever, would need to know how many particles. Okay? It's not to say you won't do it. It's just not a common conversion. Who's got questions on that? Yeah.
I did not understand 15.
Louder?
15?
15? Okay. For you way in the back, is this big enough? Am I right big enough? See, a little bigger? Okay. Can you see that 15 okay? All right. I know last name's Shaver. First name?
Bria?
Bria. Tell me what the question is.
What is the mass in G of 6.30 molecules of penicillin?
Say that again, the last part.
6.30 moles of penicillin.
Okay. So you're going to start off with 6.30 moles of penicillin. You're going to need to read me the formula. C.
C16, H18, O4, N2S.
Thank you. Bria, what did you do? Because you should have had at least this set up. Or did you not have that set up?
I honestly have no clue what I did.
So you want to make sure that you're doing the same things as we did when we were just doing regular conversions. So you always start with what you're given, times blank, same unit down the bottom. No difference. Okay? Other than that, I can tell you right now, if you're using moles in a conversion, it's going to be a 1. Right now. Okay? That's going to change later this semester. But since we're only doing gram mole conversions right now, that's going to be 1 mole. What do you do now, Bria? Do you know?
The masses?
Add up the masses. Now, since this is 1 mole, what's the mass going to be up on the top? Because we've got 2 masses that the periodic table can represent. It can represent mole or grams in 1 mole, or atomic mass units for 1 particle. So if we add them all up, you get the same number, but if this is a mole, what unit of mass are we going to be doing?
Grams.
Does anybody have that added up? 14 point what?
36. Someone check me on that.
I got it.
Confirm or deny? What do you have? 414?
Like, no, like the question.
No, I'm with, is it?
I got 334.43.
So 334?
Point 43.
4.43.
And what do you get for your answer? You guys gonna have to speak up. Who would just answer that?
Do you want me to answer?
Yes, loud and proud.
2,106.
No!
Oh, we take, scientific.
Oh
notation.
yeah.
Okay, then, it's 2.11 times 10 to the third.
There you go. Alex?
So there was an owl a while ago, and it had us do like the conversions owl, but on the bottom there was also like a mole part. So there I didn't know how to do it, so I searched it up, and I got like these formulas to like for that, but without all the work. So like if you're looking for moles, mole is equivalent to grams over the mass, and then grams is equivalent to moles times the mass. I like plugged it in and got the same answers, so it works out. But should we use that? Like,
You know,
on
those
the
are all
test?
fine and dandy if it's just 1 step.
Okay.
You do it my way, or you hit the highway.
Yeah.
Your choice. Okay? Lana?
I think I set it up differently, but I did the same thing.
Okay, say it again. You set it up.
Like, I think I set up my numbers differently, but I was doing the same thing, like the same concept. I just wrote it out differently than how you wrote it out.
Open up your Canvas app, or open up the Collage app on your iPad. You'll probably have to search for it. It should be there though. I think they automatically push that thing out.
Yeah, I'm not watching that.
You have it? Okay. So in the upper right corner, class, listen along with this. And just follow along. I'm going to have only Lana follow through on this. Because you're going to have to do this sometime this year. Okay? Probably sooner rather than later. So if you haven't done this, pay attention. So Lana, up in the upper right is the little gear. Is that right? Or is it upper left? Okay, upper left. Switch it to advanced. And then you're going to be able to get this code in there. The advanced code requires, it allows me to okay before somebody puts something up on the screen. Okay, so you should have a thing that says share or start.
Disconnected.
Or can, I know.
Then you have to screen it.
Okay. Now, remember how we did this with AirPlay on Apple with Apple TVs or no?
Yeah.
So swipe down from the top corner
What-
and do the screen share, and it just says collage. I think if you scroll all the way down to the bottom, it will say collage. Let's put it this way. This is the clunkiest thing. All right.
That's how I did it.
Okay. So and that's what Alex is talking about. Okay.
I just did like the.
You got, so here's the thing, I know what you did, you, because mathematically, what I had up there is multiplying these two numbers together, which you've got.
Yeah.
And you've added this up correctly, okay? But when you're going through and setting up the dimensional analysis, everything needs to be done in that dimensional analysis. So you want to make sure that you're doing that. You know, you're starting off with your 6.30 moles of penicillin times blank. This is where this on top, okay, and then your 1 mole of penicillin on the bottom. Class, you're going to see really quickly today why this is the case. All right? I'm teaching you a method of problem solving and approach that is going to be used and built upon. Okay? This is the foundation. This is our first little brick. As long as we get this placed right, everything's going to be good. Okay? Now, Lana, I'm glad you have this up here because I want to point out to everybody, this, all of this, I never want to see. You don't need to show it. Because that's just calculator stuff, right? So when you're adding these up on your calculator, it's just 16 times 12.01 plus 18 times 1.01 plus 4 times 16. Just boom, 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 boom on your calculator. All right? I don't need to see that work. It's a waste of time for you guys to write it out and stuff. Wean yourself off of it. Okay? So Lana, did you do any of them with the mole conversion like that?
Nope.
Okay. So you're gonna get practice today. Okay. You can disconnect that now. Who else has questions? So all the ones I assigned, you had a place in the quiz to check your answers, correct? Mm-hmm. Nothing major differences there? I mean, I did something right for a change? Okay. All right. So get out that the document that these questions came from. Oh, I just need to allay my fear. Everybody go into Drive, Google Drive, and make sure that my folder is there and you can open up one of the documents. Because yesterday, access got screwed up somehow.
I don't see anything.
Everybody,
I don't see anything.
Who said they don't see anything? Okay.
Where do you want us to go?
Anything in Drive, just to make sure that you can see it and open something up. Because yesterday, all of the sharing things got broken. Abby?
Can I go to the bathroom? May I?
Okay, scroll down to number 29. Now with these questions, hopefully you can start seeing why you need to know the element names and formulas. So aluminum sulfate. You now know that if you see that name, it's made up of aluminum and sulfate. Now the numbers of each one are maybe a little bit weird. We'll learn how to do that later. But you can see it's got aluminum and sulfate on it. So it's a compound used in sewage treatment plants. How many atoms are in one aluminum sulfate molecule? Now, I'm skipping over questions 27 and 28 to show you how this is going to be done. So in question number 29, I'm going to write it out as if it were a conversion factor. Now here's the thing. You're not going to need to write these out as conversion factors. You're going to use them as conversion factors, but they don't need to be written out as such. I'm just going to show you where these things are coming from. Okay? So, how many atoms of sulfur in one aluminum sulfate molecule? So one molecule of aluminum sulfate is equal to 3 atoms of sulfur. Everybody all right with that? But that's as a conversion factor. Now here's the thing. I just got done saying, you don't need to write this out. But you need to recognize that you can use these subscripts as conversion factors if need be. Okay? How many moles of aluminum are in 1 mole of aluminum sulfate? So if I had 1 mole of aluminum sulfate, how many moles of aluminum would I have?
I think you would have 2 moles of aluminum.
Why?
Because just like if we scaled everything up to 1 mole, then aluminum, like 2 aluminum atoms would mean 2 aluminum moles. When aluminum sulfate is a mole.
Exactly. Now, these ratios, these conversions are unique to this compound. Okay? So the compound's going to give you what the conversions are. Now what Brooke said, go away. What Brooke book says absolutely how this is done. We went from one molecule having 3 atoms of sulfur to talking about moles. But if we go back to what the very first question for clarification was today, 6.022 times 10 to the 23rd particles equals 1 mole, right? So if I had 6.022 times 10 to the 23rd of this compound, how many atoms of sulfur would we have?
6.0 something to the 23rd because you're multiplying the whole thing.
Times 3. Well, if it's just times 3, then if we're doing it as moles, same basic idea. If I had a mole, which means I've got 6.022 times 10 to the 23rd of this. How many aluminum atoms are in that? Twice as many. So 6.022 times 10 to the 23rd is a mole. 2 times a mole is 2 moles of aluminum. That's all there is to it. It's why also I said earlier, we don't use the 6.022 times 10 to the 23rd that often. Because usually the unit we're using is the mole. Construct a conversion factor in moles for a relationship between, we just did it, okay? All right, there's a different worksheet I need to get uploaded. Okay. Here's your question. This is not on the worksheet. So, in the homework for today, you did problems where you were just simply converting between grams and moles of a single element or compound. We can extend those because you have conversion factors now, and I just showed you how you can make a conversion factor within a formula. Now I know you're going, oh, this looks hard. What's the first thing you have to do? No matter what, what's the very first thing I should see?
Equals grams of oxygen, so you just need to find the oxygen.
So how do we start setting it up? What's the very first thing I should see written? No matter whether you know how to do this or not, every single problem. Right?
4.68 moles of sodium chlorate multiplied by moles on the bottom of moles of sodium chloride.
That is the bare minimum I should see written when you are starting a conversion. Now here's the thing. You don't have a list of conversion factors. You have a reference, and there are many thousands of conversion factors on this periodic table. And many thousands of different conversions between moles and moles depending on what the formula is. Now, We have the unit of moles of sodium chlorate. What are we trying to get to?
Grams of oxygen.
Trying to get to grams of oxygen. When you are converting between two different substances, sodium chlorate and oxygen, you must have a conversion where you do a mole to mole conversion. If I had 1 mole of that compound, we just did this in the previous question, can I get to moles of just oxygen? Abby, what would it be?
Would it be 3 moles of oxygen?
Absolutely. Why is that important? Because that allows us to do our next step and final step. What's going on bottom?
Moles of oxygen.
How many?
1.
Because what's going to go up on top,
Mass of 1.
which is Abby?
Can we write out the mass of oxygen? Do you want us to put 16.00?
I don't care. I do. Sometimes I don't. Most of the time I do.
Oh.
It's just habit for me. This conversion right here that came from that formula. This conversion from your periodic table. That's where your conversions are going to come from right now for the foreseeable future. They're going to come from the formula of the compound that you have and the periodic table. The formulas are going to give you mole to mole conversions. The table gives you gram mole conversions. If you have grams, how many moles always for right now? 1 mole. Because on this periodic table, all of these masses represent 1 mole. Let's do another one. Can somebody tell me what the name of this compound is? Calcium phosphate. Do you understand why I had you memorize what I had you memorize? So we can speak chemistry. Okay? All right. Who is utterly confused about what we're doing right now? Lana?
I was at first, but I think I'm picking it up.
Okay, then you're going to tell me what to write up here. Ready? Give it a shot.
The 0.563 moles of calcium phosphate. And then times, and then on the bottom, we'll do the moles of calcium phosphate and just one.
Sophia, am I still writing large enough for you? Dang it. Brooke,
That's me.
what?
Brooks over here.
Oh, Brooke's there. What is it? Abby. Oh, you're the other Abby. Okay. Abby, am I still writing big enough for you?
Yeah.
Sorry. All right. Keep going.
Would it be 8 moles of oxygen?
Yes. Why?
The 4 times the 2.
So that 2 distributes through. Just in the parentheses though, right? Okay.
And then times, and then on the bottom, 1 mole of oxygen, and on top, 16 grams.
Good job.
Yay.
Calculate it. Yeah, you calculators, people. Everybody should be doing these. The only way you get good at using your calculators is using your calculators. Abby?
Are we doing significant figures?
Always.
And are we doing scientific notation?
Always.
We're doing assignment management.
Yes.
Are we doing the 686?
So we tell an answer.
Yes. 7.21 times 10 to the
Let's send the
first.
first,
Yeah.
second.
Mine says first.
So it's just.
Yes.
Would it be 3 decimal places because of the?
No. 3 significant digits.
Oh.
Yeah, so be careful about that. Remember, significant digits is how many, not how many decimal places. Okay?
So when you do significant digits, it's the number of sig figs in the original equation, not like
Correct.
across all.
Correct. And I think I told you guys that that's not how we actually do it, real world, but for you guys starting out, that's what we're gonna go with, okay? You got enough to learn and build on without having a whole bunch of other rules that really don't matter to us for the most part, okay? You okay?
Wait, can you repeat why you would do, why it's 3 significant digits instead of it being 2 decimal places?
So this has, we only look at these, so we look at, that's my uncertain digit, right? 1, 2, 3 significant digits. Your final answer should only have 3 significant digits. Not decimal places, but 3 significant digits.
Well, I said 2 because of the 16.009.
And that's why we're not looking at these numbers in here.
Okay.
But since you asked, that has 4 significant digits.
Mhm.
That only has 3.
Yeah.
So when you
But-
multiply, you go with the one with the least.
Yes, but didn't like one of the things say that if one of them had like
Oh, you're thinking of the add subtract.
Oh, okay.
I knew where you were going. I knew where you were going. Okay? Again, why I'm not going to worry about those rules, because it's just cluttering stuff up here. I want to do what's the most important. Okay? Other questions? It's still going to be 5.6. I just didn't want to do blue. And here's the thing about conversions, people. We don't do them all the exact same way. We've got a common place or a common set of conversions that we can use, so where we begin or end may differ. In this case, I'm starting with grams and ending with grams. Okay? Who wants to lead me through it?
You want to set up whatever it is first. You set up the fractions, so 5.6 grams of chromium times, on the bottom you put, on the top you put potassium chromate. Okay.
Start with the bottom.
Okay, on the bottom you put just 1 gram of, okay, you put potassium chromate, okay.
Oh, let me try this.
Oh, okay, chromate.
Just chromium?
No. You put grams of chromium.
Let's start. Where do we get gram conversions at? Can you tell me what's going to go in the top and bottom now?
You put, wait, but then where's potassium chromate gonna go?
We're not there yet.
Okay,
It's kind of like converting from kilometers to inches. We don't have a straight kilometers to inches conversion. We've got to take some steps, baby steps.
so
That's our conversions here.
Okay, then I guess you put, 52.00?
That's on bottom. What's on top?
Do you find the potassium chromate somewhere?
Not yet.
Um,
On the periodic table, what do those masses all represent? If they're grams, they all represent
1
1
mole.
Everybody okay now? Now that you have the mole, so what's going on bottom?
A mole of,
Look at your units. No, up on the screen. Why is this grams of chromium? Has to be.
because Because there's a mole on top, so 1 mole.
No. Why does that have to be grams of chromium? This goes to the heart of why we do dimensional analysis the way we do.
Because you can't make it up. I don't know.
What does this do to that?
Oh, it cancels out.
That's the whole idea. Remember, our setup with our units is to make sure that the units we don't want cancel. Right? So this is part of the automatic stuff. You're right, mole's going to go on the bottom there, but mole's of what? Well, look at the previous conversion.
Chromium, because we're canceling it out again.
Exactly. Now, we can start looking around for other conversions. Yes, I understand that the periodic table has moles built into it. But we just used that conversion. We don't want to use it upside down again, right? So where's the other place now that we can get mole conversions? Go ahead. Yeah. This is where we want to put our potassium chromate.
Okay.
How many of what? How many of each?
There's just grams of potassium chromate.
Not grams.
Oh, then just a mole of potassium chromate.
How many?
1.
Whoa. And on bottom?
Grams of potassium chromate. No, because we gotta get that.
How many moles?
1.
Why?
Because there's only 1 in potassium
Perfect.
chromate.
Perfect. Perfect. That's where we get that. Everybody doing okay? All right. It's not easy the first time, right? But you're going to do this hundreds of times. We're not done yet, though, right? Because what unit do we want?
We want grams.
Now what? Abby?
This is kind of a shot in the dark, but is the next one on the bottom, 1 mole of potassium chromate, and then on the top, it's the weight of the potassium chromate in grams.
Does anybody have that out of that?
Is it 194.2?
I don't know.
Whoa, I got.
I think I'm wrong.
Okay, I'm
I
gonna go
have
with
the definition, so.
Is 194.2? Can somebody confirm that? Okay. We got a confirmation. I don't know if it's right. We got one confirmation, so we'll go with it. Can somebody do a third? Can we get a third on that?
177.
I got you. Hold on.
How did you?
Where's the coach?
Oh, yeah, you gotta have it.
No,
That's right.
That's right?
That's
I'll,
right.
I'll let you
Okay.
guys add it up, because I don't really want that.
So, all our units cancel out. Moles of chromium, are moles of potassium chromate, moles of potassium chromate, grams. That's what's left now. So what do we get for our final answer?
2.1 times 10 to the first.
Any questions?
I have a question. How can you get grams of potassium chromate from just chromium? Like how is that possible?
Like that.
But how can like potassium chromate be in chromium? Like I don't understand.
Well, this formula has chromium in it, right?
Yeah.
So if I had 10 grams of chromium, there's only a certain amount of potassium chromate that we could have.
Okay.
It looks weird. I know the question looks
So like we're like calculating how much chromium within the potassium chromate
but in this case, so let me go, let's do this. What's the name of that?
Sodium.
Sodium
So,
oxide.
Sodium oxide.
Sodium oxide.
That's what I'm calling it.
That's what I'm.
Sodium oxide.
Yeah.
I mean, so that's nomenclature. It's not rocket science, people. Put the two freaking names together and you got the thing, okay? Now, writing out the formulas is a little bit different, but we'll get to that. All right, so. Lexi?
Yeah.
Lexi,
Yeah.
start walking me through it. Tell me what to do.
Okay, so you have 24.6 grams of sodium oxide on top. And then
No, stop.
we're gonna do 2 grams of sodium on the bottom use the top brass, so that's 22.99 grams of sodium in 1 mole of.
No, not yet. What unit has to go on? Let's just do the unit. What unit has to go on bottom?
Grams.
Grams of
Sodium.
class. That's key. Because your instinct is to start trying to get to the thing you're trying to get to. And I'm trying to tell you, stop, take a breath, and do it the way that Mr. K is showing you. Okay? Are there shortcuts to these things? Yeah. You're not smart enough for them yet. Okay? I'm sorry. I mean, you got to start someplace. In math class, do they go straight to the shortcut? No, they don't. I guarantee you they don't.
Yes, they do.
Yeah.
No, they show you the long way first.
No,
No.
like, oh yeah, so this is how you multiply by 9. You count.
No,
And then you
that's,
go
I'm not talking about that kind of stuff. I'm talking about when you get into like logarithms and things like that.
You should have seen Flash.
All right.
It's all about tricks.
What number has to go down there?
1.
Not 1. The mass of that. So you're going to take 22.99 times 2 plus 16. And what's going to go on top? 1 mole. Of what? Sodium oxide. What's going on our next blank on the bottom? Has to. Well, at least mole of sodium oxide. Yes, right now it's going to be 1. Now, Lexi, what's going on top?
This is going to be moles of sodium.
How many?
2.
Why?
Why? Because there's 2
And now what?
we're going to do moles to grams, so 1 mole of sodium is 22.99 moles on the bottom.
Okay? Who's going to answer? Bruh?
1.82 times 10 to the first grams of grams of sodium.
Confirm?
And plus
Okay. Guys, any questions? You have to think about this a little more than what you have to do with the English metric stuff? Yes, but the more you do it, the easier it's going to get. Okay? Something that I'm going to say throughout the year. Oh, that's teeny tiny. This right here. Remember I said, anytime you're going in between two different substances, you have two different things. You have to do a mole to mole conversion. And where does that conversion come from, Lexi?
From the formula.
From the formula for the compound. Okay.
So mole to mole is from the compound, and mole to gram is from the periodic table.
Yes. Now, I don't know if I told you guys that this promise, or promise not to lie to you, right? Right now, mole to mole comes from the compound. So that's going to change later, okay? But right now, for what you're learning and doing, mole to mole is coming from the compound only. All right? Now, class. We don't have enough time for me to go through a couple more problems, but I do just want to illustrate something here. What if this question was not asking for grams of sodium, but simply moles of sodium?
We would have just left it at that conversion.
We would stop right here. So that's the thing about conversions. Once you got, for most of the time, unless it's a fractional conversion, right? Once you get the unit on top that you're looking for, you stop. Don't go any further. So if this were moles, we would be stopping here if looking for moles. Questions? Okay, I apologize. You are going to have some problems to work. I don't have the problems up in Drive for you yet. I thought there were in that worksheet, but there are not. So I have one that I need to get uploaded. So I'm probably not going to be able to get to it until 5th period because we don't have any breaks today because I don't, or at least D lunch. Because I have class all the way up to D lunch. So I will get those up and tell you which problems to work. Probably be about 10 questions. Remember what I said last time about the practice. I'm going to give you enough to tell when, because if you don't understand how to do some of the problems, assigning 10 or 20 doesn't matter. If you know how to do them, after the first 3, assigning 30 problems isn't going to do anything. Why 10? Because this is one of those things that you need to get really good at and be relatively quick about it. So it's a happy little medium.
So we don't mess with any of the quote-unquote documents and answers for now. We wait until you post something else.
Yeah, so I don't have anything for the questions that I want you to do.
Right.
I don't think I have one up.
Okay, so just wait until you post whatever is your period.
Yeah.
Alrighty. thank
I will
you.
get it into Drive and I'll send you guys an email. Okay? Alex, can you hit the stop on that, please?